October 23, 1944. Leyte Gulf, Philippines. Captain Tomiji Koyanagi stood on the bridge of the heavy cruiser Yamato, watching through binoculars as the horizon filled with ships. Not dozens, not hundreds. The American fleet extending before him contained over 700 vessels. Koyanagi had served in the Imperial Japanese Navy for 23 years. He had studied American naval capacity at the Naval War College in Tokyo. He had read intelligence reports. He had reviewed production estimates. Yet nothing in his training or experience had prepared him for what he was witnessing. The mathematical impossibility of it paralyzed his tactical thinking for several crucial seconds. 3 years earlier, in December 1941, the entire United States Pacific Fleet had consisted of approximately 94 vessels. Japan's surprise attack at Pearl Harbor had reduced that number significantly. Japanese naval planners had calculated that even if America rebuilt aggressively, it would take 5 to 7 years to match Japan's existing fleet strength. The Americans would be forced to negotiate to accept a compromise peace before their industrial capacity could overwhelm Japan's early victories. The calculation was logical. It was based on sound naval construction principles that had governed shipbuilding for decades. And it was catastrophically wrong. By October 1944, less than 3 years after Pearl Harbor, the United States Navy possessed over 6,000 vessels. Not a modest fleet rebuilt to pre-war strength, but an armada larger than all other navies in human history combined. The transformation represented an industrial achievement so profound that even after seeing it with their own eyes, Japanese naval officers struggled to accept it as real. Some insisted American ships must be poorly constructed, hastily assembled vessels that would prove unseaworthy. Others claimed the Americans were counting small craft and support vessels to inflate statistics. A few speculated that the intelligence reports were simply wrong, that no nation could possibly build ships at the rates being reported. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The disbelief was understandable. The Japanese Navy had spent decades building a fleet through careful planning and traditional shipyard methods. Each vessel represented months or years of skilled craftsmanship. The idea that ships could appear by the hundreds through some revolutionary production process contradicted everything Japanese naval officers had been taught about maritime construction. The story of how America built a 2,000-ship fleet in 18 months begins not with naval architects or admirals, but with the same man who had revolutionized merchant shipping, Henry Kaiser. In early 1942, Kaiser's shipyards were already transforming cargo vessel production using prefabrication and welding techniques that traditional shipbuilders had dismissed as impossible. Vice Admiral Emory Land, chairman of the United States Maritime Commission, watched Kaiser's merchant ship production with growing interest. If cargo vessels could be built in days instead of months using assembly line techniques, what might be possible with warships? The question was heretical to traditional naval thinking. Warships were precision instruments, far more complex than simple cargo carriers. They required armor, sophisticated fire control systems, complex engineering plants, weapons systems, communications equipment. Naval architects spent years designing each vessel class. Shipyards spent months or years building them. Kaiser had never built a warship. His experience was entirely in merchant construction and civil engineering. Yet Land recognized that Kaiser's ignorance of naval tradition might once again prove to be an advantage, rather than a limitation. In April 1942, Land approached Kaiser with a proposal that naval contractors considered absurd. The Navy needed escort carriers, small aircraft carriers that could be built quickly to provide air cover for convoys and amphibious operations. Traditional escort carrier construction converted existing merchant hulls, a process that still required 8 to 10 months per vessel. Land asked Kaiser whether his prefabrication techniques could accelerate production. Kaiser's response was characteristically audacious. He promised to build 50 escort carriers in less than 2 years. Naval constructors calculated this was impossible. Traditional methods would require 5 years to build 50 carriers using every available shipyard. Kaiser proposed something entirely different. He would build the carriers the same way he built Liberty ships, as prefabricated assemblies welded together on abbreviated construction schedules. The Navy, desperate for escort carriers and willing to try anything that might work, authorized the program. Kaiser established a new facility at Vancouver, Washington, specifically designed for escort carrier production. The yard was laid out like his Richmond facility, with extensive prefabrication areas and assembly line principles. Workers who had been building Liberty ships weeks earlier found themselves constructing warships using the same techniques. The first escort carrier, USS Casablanca, was laid down in November 1942. Traditional escort carrier construction required 8 to 10 months. Kaiser delivered the Casablanca in 6 months, a substantial improvement, but still not the revolutionary speed he had promised. The second carrier required 5 months. The third required 4 months. By the 10th carrier, construction time had fallen to less than 3 months. The escort carriers, designated the Casablanca class, were not elegant vessels. Naval architects considered them minimally capable. They lacked the speed, armor, and aircraft capacity of fleet carriers. Their range was limited. Their construction was basic, but they were adequate for convoy, escort, and ground support operations, and they appeared in quantities that transformed Pacific operations. By the end of 1943, Kaiser's Vancouver yard was completing an escort carrier every 3 weeks. Traditional naval constructors watched with the same mixture of disbelief and forced acceptance that had characterized their reaction to Liberty ship production. The prefabrication approach proved as revolutionary for warship construction as it had been for merchant vessels. Instead of building ships sequentially from keel to deck, Kaiser's yards fabricated entire sections simultaneously. Flight decks were assembled in one area, while hull sections were welded in another area, and engineering plants were installed in a third location. When sections were complete, massive cranes positioned them on the building ways, where welding crews joined them in days rather than weeks. The Vancouver facility eventually produced 50 escort carriers in 19 months. Not 2 years as Kaiser had initially promised, but 19 months. The average construction time per vessel fell to approximately 11 days from keel laying to launch. Think about that number for a moment. 11 days to build an aircraft carrier, not a merchant ship, not a simple craft, but a warship capable of launching and recovering aircraft, with armor, weapons, sophisticated equipment. The Casablanca-class carriers were small compared to fleet carriers, displacing about 10,000 tons fully loaded, but they could carry up to 28 aircraft and provided essential air support across the Pacific theater. They participated in operations from the Marianas to Okinawa. Several were sunk in combat, proving they were seaworthy enough to operate in combat zones and survive battle damage that would have sunk lesser vessels. But escort carriers were only one part of America's naval expansion. The true scale of production involved hundreds of different vessel types, each built in quantities that would have seemed impossible just years earlier. Destroyer escorts represented another class of vessel that appeared in revolutionary numbers. These were small destroyers designed primarily for anti-submarine warfare and convoy escort. Traditional naval construction would have required 18 months to build a destroyer escort. American shipyards, applying Kaiser's prefabrication principles and assembly line techniques, reduced construction time to less than 6 months on average. Some yards achieved construction in less than 3 months. Between 1943 and 1945, American shipyards built 563 destroyer escorts. That's an average of more than 1 destroyer escort completing every 2 days for 2 years straight. The vessels weren't perfect. Naval purists criticized their simplified systems and limited capabilities, but they were present in quantities that allowed the Navy to assign escorts to nearly every convoy, to hunt submarines aggressively rather than defensively, to establish anti-submarine barriers that German U-boats found increasingly difficult to penetrate. Full-size destroyers saw similarly remarkable production. The Fletcher-class destroyer, one of the most successful destroyer designs ever built, was produced in quantities that traditional naval planning considered impossible. A Fletcher-class destroyer displaced 2,100 tons, required sophisticated fire control systems, carried 5 5-inch guns, multiple anti-aircraft weapons, torpedo tubes, depth charges, and radar systems. This was not a simple vessel. It was a complex warship requiring precision engineering and skilled construction. Yet American shipyards built 175 Fletcher-class destroyers between 1942 and 1944. The Bath Iron Works in Maine achieved construction times of less than 6 months per destroyer. Some vessels were completed in as little as 4 months, from keel laying to commissioning. The production represented a complete transformation of naval construction philosophy. Before the war, Building a destroyer required careful craftsmanship, with skilled workers solving problems individually as they arose during construction. American wartime production treated destroyers as manufactured products rather than craft objects. Detailed specifications standardized every component. Workers installed prefabricated assemblies rather than building from raw materials. The same worker might install the same component on dozens of destroyers, achieving speed through repetition rather than comprehensive skill. Japanese naval intelligence received reports of American production numbers throughout 1943 and 1944. The reports were discounted as obvious exaggeration. Japanese naval officers calculated destroyer production rates based on their own construction experience. Japan's shipyards, considered excellent by international standards, required 12 to 18 months to build a destroyer. The Japanese Navy had invested heavily in quality, building some of the finest destroyers in the world. Japanese destroyers were faster, more heavily armed, and more capable than most American destroyers in one-on-one comparison. But the Americans weren't building destroyers for one-on-one battles. They were building them by the dozens, eventually by the hundreds, creating numerical advantages so overwhelming that individual vessel quality became almost irrelevant. A Japanese destroyer might be superior in specific capabilities, but when it faced 3 or 4 American destroyers simultaneously, superiority didn't matter. The mathematics of overwhelming numbers decided battles before the first shot was fired. Submarine production demonstrated the same patterns. American shipyards built 203 submarines during the war. Japanese shipyards built 126 submarines during the same period. The disparity wasn't as dramatic as in surface vessels, but it was significant. American submarines operated with logistical support that Japanese submarines never achieved. American submarines could remain on patrol longer, receive replacement torpedoes at forward bases, obtain spare parts quickly when needed. Japanese submarines faced chronic shortages of everything: fuel, torpedoes, spare parts, trained crews. American production created abundance that transformed operations. Damaged submarines could be repaired quickly because parts were readily available. Crew training programs had ample submarines available for training exercises. Commanders could be aggressive knowing that lost vessels would be replaced. By 1944, American submarines were sinking Japanese merchant shipping faster than Japan could replace vessels. The same production advantage that Germany faced in the Atlantic manifested in the Pacific. Japan couldn't build ships faster than American submarines sank them. The material mathematics of industrial warfare were working their inevitable calculus. Landing craft represented perhaps the most dramatic production achievement in sheer numbers. These weren't complex warships requiring years of engineering development. They were utilitarian vessels designed for one purpose, delivering troops and equipment from ships to beaches. But they were needed in quantities that staggered imagination. The United States built over 88,000 landing craft of various types during the war. 88,000 watercraft. Some were small, capable of carrying a single squad of soldiers. Others were large enough to transport tanks. Many were built by companies that had never constructed vessels before the war. Small boat builders, furniture manufacturers, even companies that built truck bodies, found themselves constructing landing craft. The designs were deliberately simplified for rapid production. Many landing craft were essentially floating boxes with bow ramps, powered by automotive engines and steered with equipment borrowed from small boats. The lack of sophistication didn't matter. They transported millions of soldiers to dozens of amphibious landings across the Pacific and European theaters. By 1944, American amphibious operations could land entire divisions on hostile beaches in single days, supported by naval gunfire, air cover, and logistical capacity that Japan couldn't hope to match. The scale of American production became fully visible during major operations. The invasion of Okinawa in April 1945 involved over 1,300 vessels. Read that number again: 1,300 vessels in a single operation. Battleships, carriers, cruisers, destroyers, transports, landing ships, supply vessels, hospital ships, repair ships, salvage vessels, tankers, ammunition ships. The fleet represented more tonnage than most nations possessed in their entire merchant marine. And this was just one operation. Simultaneously, other American naval forces were operating across the Pacific, conducting operations against the Philippines, supporting advances toward Japan, maintaining supply lines stretching thousands of miles from Hawaii to forward bases, hunting remaining Japanese warships and submarines. The total number of vessels required to sustain these simultaneous operations exceeded 2,000 ships. The logistics of maintaining a 2,000-ship fleet challenged every assumption about naval operations. Traditional naval doctrine assumed fleets operated from established bases, where ships could be repaired, refueled, and resupplied. The distances involved in Pacific operations made traditional logistics impossible. American forces developed something entirely new: the fleet train. The fleet train consisted of hundreds of support vessels, tankers, ammunition ships, repair ships, supply vessels, hospital ships that accompanied combat fleets and allowed them to remain at sea for months without returning to port. Combat vessels could refuel at sea, receive ammunition transfers, obtain spare parts, even conduct significant repairs without leaving the operational area. This floating logistics system was itself larger than most nations' entire navies. The tankers alone numbered in the hundreds. Fleet oilers delivered fuel to combat vessels at sea, allowing continuous operations. Ammunition ships carried millions of rounds of ordnance. Repair ships with machine shops and skilled technicians could fabricate replacement parts and conduct repairs that would traditionally require dry dock facilities. The psychological impact on Japanese naval officers who encountered these fleets was profound and demoralizing. Captain Atsushi Oi, a destroyer commander who survived the war, described his reaction in post-war interviews. "We expected to face the American fleet as it had existed before the war. We knew they would rebuild. We thought we had 3 years, perhaps 4, before they could challenge us. When we encountered fleets of hundreds of ships just 18 months after Pearl Harbor, we understood we had fundamentally miscalculated. Not slightly miscalculated, catastrophically miscalculated. The war was already lost, but we didn't yet know it." The construction techniques that enabled this production represented a complete break from centuries of naval tradition. Traditional warship construction had changed remarkably little since the age of sail. Ships were built on sloped ways, starting with the keel and building upward in careful sequence. Each section had to be complete before the next could begin. Skilled workers fitted each plate, drove each rivet, tested each system individually. The process was methodical, careful, and slow. American wartime construction had abandoned this entirely. Ships were built in sections fabricated simultaneously across multiple work areas. A destroyer might have its bow section, stern section, and amidships sections all under construction at the same time in different parts of the shipyard. Engine rooms were assembled as complete units and dropped into hull sections as single pieces. Weapon systems were installed on prefabricated deck sections before those sections were mounted on the hull. Welding replaced riveting almost entirely, despite Navy Bureau of Ships' initial resistance. The Bureau had forbidden welding on warship hulls before the war, considering it unreliable for combat vessels. Wartime necessity forced acceptance. Welding proved not only faster than riveting, but produced stronger joints that were less likely to fail under battle damage. The standardization of designs accelerated production dramatically. Before the war, nearly every warship was unique. Naval architects designed each vessel individually, incorporating improvements and modifications. Wartime production eliminated customization. The Fletcher-class destroyers were built to identical specifications across multiple shipyards. A part manufactured in one yard would fit any Fletcher-class destroyer being built anywhere in America. This interchangeability extended to components and subsystems: engines, generators, pumps, valves, fire control systems, radar equipment, all were standardized. A damaged destroyer could receive replacement parts from any supply depot. Crews transferring between vessels found familiar equipment and layouts. Training was simplified because sailors learned systems they would find on any ship of that class. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The workforce that built this fleet paralleled Kaiser's Liberty ship program in its democratization of skilled labor. Women comprised significant portions of shipyard workforces. African Americans were employed in skilled positions previously closed to them. Workers with no maritime experience learned specialized tasks in weeks and performed them with competence that would have required years of apprenticeship under traditional systems. Mare Island Naval Shipyard in California employed over 46,000 workers at peak production. Women comprised over 25% of the workforce. The facility built 17 submarines, 4 submarine tenders, multiple destroyers, landing ships, and conducted repairs on hundreds of damaged vessels. The scale of operations at individual yards exceeded entire national shipbuilding industries in most countries. The Brooklyn Navy Yard employed over 70,000 workers during the war. The facility built the battleship Iowa, multiple aircraft carriers, and countless smaller vessels, while simultaneously conducting repairs and overhauls on hundreds of ships. The yard operated 24 hours daily throughout the war, with workers on 3 rotating shifts, ensuring production never stopped. The costs of this construction effort were astronomical but sustainable given America's industrial capacity. The United States spent over $100 billion on Navy construction and operations during the war, equivalent to trillions in modern currency. Yet this represented only a fraction of total war spending and was financed without crippling the economy. American industrial production was so vast that the nation simultaneously built the world's largest navy, created the world's largest air force, equipped millions of soldiers, supplied substantial forces to Britain and the Soviet Union through Lend-Lease, and still maintained civilian production sufficient to prevent economic collapse. German and Japanese planners had understood that America possessed greater industrial capacity than their nations. What they failed to grasp was the magnitude of that advantage. They thought in terms of America being perhaps 50% more productive, maybe twice as productive as their own industries. The reality was that American industrial capacity exceeded German and Japanese production combined by factors of 4-to-1 or 5-to-1 in most categories. In shipbuilding specifically, the disparity was even more dramatic. Japan built approximately 600 combat vessels during the entire war, from 1941 through 1945. The United States built over 6,000 vessels during the same period, a 10-to-1 advantage. The Japanese Navy possessed approximately 10 carriers at the start of the war. The United States possessed 7. By the end of 1943, the United States had over 100 carriers of all types in service, while Japan had fewer than 15 remaining. The mathematics of naval warfare had become simple arithmetic. Japan couldn't replace losses. America replaced losses within weeks and added new vessels on top of replacements. Every battle, regardless of tactical outcome, mathematically favored the Americans. The Battle of the Philippine Sea in June 1944 demonstrated this brutal calculus. Japanese naval aviation launched massive strikes against American carrier forces. American fighters and anti-aircraft fire destroyed hundreds of Japanese aircraft in what American pilots called the Great Marianas Turkey Shoot. Japan lost approximately 476 aircraft and 3 aircraft carriers. American losses were approximately 123 aircraft and no ships. Both sides suffered losses, but for Japan the losses were irreplaceable. The skilled pilots killed in that battle represented years of training that Japan no longer had time or resources to duplicate. The aircraft destroyed represented a substantial fraction of Japan's remaining naval aviation. For America, the losses were replaced within days. New aircraft arrived on escort carriers. Replacement: pilots fresh from training filled empty cockpits. Within a week, American carrier forces were operating at greater strength than before the battle. Japanese naval aviation never recovered. The remaining carriers lacked aircraft. The remaining aircraft lacked skilled pilots. The industrial capacity to rebuild simply didn't exist. By October 1944, when Captain Koyanagi watched the American fleet at Leyte Gulf, the Japanese Navy was operating with desperate awareness that they faced an enemy they couldn't defeat through conventional naval tactics. The fleet Koyanagi observed contained over 30 aircraft carriers, 12 battleships, dozens of cruisers, over 100 destroyers, and hundreds of support vessels. Japan's entire remaining fleet consisted of perhaps 60 major combat vessels. The numerical disparity was so overwhelming that Japanese naval commanders began considering suicide tactics. If conventional battle was mathematically impossible to win, perhaps deliberate sacrifice could achieve disproportionate results. The kamikaze concept emerged not from fanaticism, though propaganda would portray it that way, but from cold mathematical desperation. A conventional aircraft attacking a ship might inflict damage if the pilot was skilled and fortunate. A kamikaze aircraft flown deliberately into a ship guaranteed impact and damage. When facing impossible numerical odds, trading one aircraft and one pilot for one ship represented the best exchange rate Japan could achieve. The kamikaze attacks that began during the Leyte Gulf campaign reflected Japan's recognition that industrial warfare had made conventional naval combat unwinnable. The attacks were tactically effective in specific instances. Kamikaze strikes sank several American vessels and damaged dozens more, but strategically they changed nothing. America built ships faster than kamikazes could sink them. Pilot training programs produced new aviators faster than Japan could train suicide attackers. The mathematics remained inexorable. The construction of fleet carriers demonstrated American production capacity in its most sophisticated form. Fleet carriers were the most complex warships built during the war. They required massive hull structures, sophisticated aviation facilities, powerful propulsion systems, extensive defensive armament, complex damage control systems, and accommodations for thousands of crew members and hundreds of aircraft. Traditional naval construction required 3 to 4 years to build a fleet carrier. American wartime production reduced this to less than 18 months. The Essex-class fleet carrier represented the standard American design. 24 Essex-class carriers were built during the war. The first, USS Essex, was laid down in April 1941 and commissioned in December 1942, a construction time of 20 months. Later, Essex-class carriers were built in as little as 14 months from keel laying to commissioning. These were not simple vessels. Each Essex-class carrier displaced over 36,000 tons, measured over 870 feet long, could accommodate over 90 aircraft, and required a crew of over 3,000 men. They were floating cities, with their own hospitals, machine shops, bakeries, laundries, and complete infrastructure. The complexity made the construction speed even more remarkable. Every Essex-class carrier contained thousands of miles of electrical wiring, hundreds of separate compartments, sophisticated elevators for moving aircraft between hangar deck and flight deck, catapults for launching aircraft, arresting gear for recovering aircraft, radar systems, radio communications, fire control systems. Building one such vessel in 14 months required coordination of thousands of workers performing millions of individual tasks with precision timing. Yet American shipyards built them routinely, delivering carriers with such regularity that the Navy struggled to crew them all. The training programs for naval personnel expanded as dramatically as shipbuilding. The Navy required hundreds of thousands of sailors to operate the expanding fleet. Training facilities were established across the country. Boot camps processed recruits by the tens of thousands. Specialized schools taught technical skills, radar operation, engine maintenance, fire control, damage control, aviation mechanics. The Navy also established training programs for officers. The rapid expansion meant that experienced officers were spread thin. 90-day wonder programs compressed officer training into 3 months, producing junior officers in quantities sufficient to staff the expanding fleet. Traditional naval officers, graduates of the Naval Academy with years of sea service, viewed these rapid training programs with skepticism, similar to how traditional shipbuilders had viewed Kaiser's production methods. Yet the system worked. The hastily trained officers proved capable of learning on the job. The complexity of modern naval warfare meant that experience mattered, but the basic competence required to stand watch, navigate vessels, and manage departments could be taught in compressed timeframes when necessity demanded it. By 1945, the United States Navy had grown to over 3 million personnel. In 1940, the Navy had consisted of approximately 203,000 active duty personnel. The 15-fold expansion in manpower paralleled the expansion in ships. Finding, training, and integrating 3 million sailors represented an organizational achievement comparable to the industrial achievement of building 6,000 vessels. The Japanese Navy, by contrast, struggled with personnel challenges throughout the war. Japan began with a well-trained, highly professional navy. Sailors received extensive training. Officers were carefully educated in naval tradition and tactics, but the system couldn't scale. As casualties mounted, replacing trained personnel became increasingly difficult. Japan lacked the industrial infrastructure to build training facilities on American scales. Fuel shortages limited training exercises. Experienced instructors were needed for combat operations and couldn't be spared for training. By 1944, Japanese vessels often operated with partially trained crews. Damage control capabilities suffered particularly. American damage control training was extensive, with sailors drilled repeatedly on fighting fires, controlling flooding, and maintaining systems under combat conditions. Japanese damage control training was less comprehensive, and crew inexperience showed in battle. American ships survived damage that would have sunk Japanese vessels, not because American ships were better built, but because American crews were better trained in keeping damaged ships afloat. The carrier battles of 1944 and 1945 demonstrated this advantage repeatedly. American carriers absorbed kamikaze hits, suffered massive fires, and remained operational or were saved through aggressive damage control. Japanese carriers, when damaged, often proved impossible to save. The submarine war in the Pacific illustrated the production advantage in particularly stark terms. American submarines operated aggressively because they knew lost boats would be replaced. Commanders took calculated risks. If a submarine was damaged beyond immediate repair, it simply returned to Pearl Harbor or San Francisco, where repair facilities could restore it to service within weeks. Japanese submarines operated conservatively, knowing each boat was irreplaceable. Commanders avoided risks. Damaged submarines often couldn't be repaired due to lack of parts or repair facilities. The result was that American submarines achieved dramatically higher success rates. American submarines sank over 1,300 Japanese merchant vessels, totaling approximately 5 million tons. They also sank approximately 200 Japanese warships, including 1 battleship and 8 aircraft carriers. Japanese submarines, despite often superior torpedo technology and capable boats, achieved far less strategic impact. They focused often on attacking warships rather than merchant shipping, a tactical choice that reduced their effectiveness at disrupting American logistics. And they operated in an environment where American anti-submarine capabilities improved dramatically throughout the war. American destroyer escorts equipped with advanced sonar and radar could detect submarines more effectively than Japanese could detect American submarines. American code-breaking allowed routing of convoys around submarine patrol areas, while Japanese convoys were increasingly routed directly into American submarine patrol zones. The industrial asymmetry manifested in every aspect of naval warfare. American ships received regular maintenance. Paint, an important protection against corrosion, was available in abundance. Japanese ships by 1944 often showed extensive rust and deterioration because paint and maintenance supplies were unavailable. American ships received equipment upgrades routinely, new radar systems, improved fire control, better anti-aircraft weapons were installed during brief overhauls. Japanese ships made do with original equipment because replacement systems weren't being manufactured in sufficient quantities. American ships carried ample spare parts. Critical components could be replaced at sea or at forward bases. Japanese ships operated with chronic spare parts shortages, meaning minor mechanical failures often rendered equipment inoperable for extended periods. The accumulation of these small advantages created dramatic operational differences. American fleets could maintain high operational tempos for months. Japanese fleets could manage brief intensive operations but couldn't sustain extended campaigns. The industrial foundation made the difference. When Vice Admiral Mark Mitcher's Fast Carrier Task Force operated continuously for months in 1944 and 1945, conducting strikes against Japanese positions while remaining at sea, supplied by the fleet train, the feat was only possible because of the industrial capacity that built hundreds of support vessels and kept them filled with fuel, ammunition, spare parts, and supplies. Japanese Admiral Jisaburo Ozawa, commander of Japanese carrier forces, understood the impossibility of his position by mid-1944. His post-war testimony at naval interrogations revealed the psychological impact of facing overwhelming industrial superiority. We knew American industrial capacity was greater than ours, but we thought the difference was manageable. We thought we could win decisive battles, sink enough of their ships, and force negotiations before their industry overwhelmed us. We didn't understand that American industry could build ships faster than we could sink them, train crews faster than we could kill them, and produce aircraft faster than we could shoot them down. By 1944, every battle we won was actually a defeat because we lost resources we couldn't replace, while they replaced everything we destroyed within weeks. The war became mathematically unwinnable, but we kept fighting because surrender was culturally impossible. The construction program peaked in 1944. American shipyards launched over 4,000 vessels that year, an average of over 11 ships per day. The number included everything from massive battleships to small patrol craft, but the scale was unprecedented in human history. For comparison, Britain, at the height of its imperial naval power, in the early 1900s, had built approximately 150 vessels annually. The Soviet Union, during its maximum Cold War shipbuilding, never exceeded 1,000 vessels annually. America, in 1944, built 4,000 vessels in 12 months, and this was while simultaneously building 1,500 aircraft monthly, producing millions of tons of ammunition, manufacturing thousands of tanks and trucks, and supplying allies with massive quantities of equipment through Lend-Lease. The victory in the Pacific was ultimately an industrial victory. American military forces fought courageously and skillfully. Individual battles were won through tactical competence and personal valor, but the outcome of the war was determined by production statistics. Japan couldn't sink ships faster than America built them. Japan couldn't kill sailors faster than America trained them. Japan couldn't destroy aircraft faster than America manufactured them. The mathematics were inexorable, and Japanese military leaders understood this increasingly clearly as the war progressed. By 1945, Japanese planning focused not on winning, which they recognized as impossible, but on inflicting sufficient casualties to make invasion of the home islands costly enough that America might accept negotiated surrender rather than unconditional surrender. The kamikaze campaigns, the preparations for final defensive battles, the acceptance of mass civilian casualties, all emerged from recognition that conventional military victory was no longer possible. The atomic bombings of Hiroshima and Nagasaki in August 1945 ended the war before the industrial asymmetry could manifest in its final, most terrible form. American planning for the invasion of Japan, Operation Downfall, scheduled for November 1945, involved over 5,000 vessels. The largest amphibious operation ever conceived would have employed more ships than had participated in all previous amphibious operations combined. The invasion never happened, but the planning revealed how completely American industrial capacity dominated the Pacific by war's end. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe. The Essex-class carriers remained in service for decades after the war. Several were modernized and operated into the 1970s, over 30 years after their wartime construction. The longevity vindicated the wartime construction methods that traditional naval architects had questioned. Ships built in 14 months proved durable enough for 3 decades of service. The destroyer escorts built in months remained in American service through the 1960s, with many transferred to Allied navies where they served into the 1980s. Some of the landing ships built so rapidly during the war remained operational into the 21st century, over 60 years after their construction. The organizational lessons proved as valuable as the physical vessels. The United States Navy absorbed lessons about rapid construction, standardization, and industrial warfare that influenced naval planning throughout the Cold War. The ability to rapidly expand production in wartime emergency became a planning assumption. The Korean War and Vietnam War naval operations relied on reserve fleets of World War II vessels maintained in mothballs, specifically because wartime experience proved that building large fleets required years of preparation. The Soviet Navy during the Cold War built large numbers of submarines and surface vessels, but American naval planners remained confident that American industrial capacity could outproduce Soviet shipyards in any extended conflict, just as it had outproduced Japanese and German yards during World War II. The confidence was rooted in demonstrated historical achievement. The workforce that built the wartime fleet carried skills and confidence into peacetime careers. Women who worked as welders and riveters during the war faced post-war pressure to return to domestic roles, but many retained their technical skills and found employment in industries that valued their capabilities. The integration of women into industrial workforces during the war, while partially rolled back after 1945, established precedents that would eventually lead to permanent changes in workplace demographics. African American workers who gained skilled positions in wartime shipyards similarly carried those experiences forward. The contradiction between fighting for freedom abroad while facing discrimination at home created pressure for civil rights advances that would accelerate in the post-war decades. The Navy itself began slow integration during the war, driven partly by personnel shortages that made racial segregation increasingly impractical. The industrial achievement of building 2,000 ships in 18 months stands as perhaps the most dramatic example of American productive capacity during World War II. The Liberty ships and aircraft production receive more attention in popular history, but the naval expansion was arguably more significant strategically. Control of the seas determined whether armies could be supplied, whether air forces could reach enemy territory, whether economic pressure could be applied through blockade. Japan's strategy had assumed America couldn't project naval power across the Pacific rapidly enough to matter. The assumption was based on reasonable calculations about traditional shipbuilding capabilities. What Japanese planners failed to anticipate was that traditional shipbuilding capabilities would be revolutionized through application of mass production principles developed in other industries. Henry Kaiser's contribution to naval construction paralleled his influence on merchant shipping. While Kaiser himself didn't build the destroyers, battleships, and submarines that formed the core of the fleet, his demonstration that ships could be manufactured using assembly line techniques influenced naval construction across the industry. Shipyards, that had built vessels using traditional methods for decades, adopted prefabrication, welding, and standardization. Because Kaiser proved these approaches worked, the naval officers who had resisted welded construction and simplified specifications were forced to accept that results mattered more than tradition. The ships built using improper methods proved combat effective. The vessels constructed by unskilled workers performed as well as ships built by traditional craftsmen. The crews, trained in months rather than years, proved capable of operating complex vessels competently. Every assumption about limitations was challenged and proven wrong. The revolution in naval construction techniques that occurred between 1941 and 1945 influenced global shipbuilding for decades. Japanese and European shipyards rebuilding after the war studied American wartime methods. The prefabrication and modular construction approaches became international standards. Modern naval shipbuilding still relies on principles pioneered during World War II. Vessels are built in sections fabricated simultaneously and assembled on abbreviated schedules. Welding is universal. Standardization of components and systems is routine. The revolution proved permanent. Captain Koyanagi survived the war and returned to Japan in 1946. He spent his remaining years analyzing the naval conflict and teaching at maritime institutions. In a 1967 interview, 22 years after the war ended, he reflected on the moment at Leyte Gulf when he first comprehended the scale of American naval power. I had studied American industrial capacity. I had read reports. I thought I understood. But understanding through reports is different from seeing with your own eyes. When I watched that fleet extending to the horizon, I realized we had never truly understood what we were fighting. We thought we faced a nation. We were actually fighting an industrial system that could build faster than we could destroy. The war was lost, not when we surrendered in August 1945, but in December 1941, when we chose to fight an enemy whose industrial capacity we had fundamentally misjudged. The story of how 2,000 ships appeared in 18 months of welding is ultimately a story about the transformation of warfare through industrial capacity. The romantic notions of naval combat, battles decided by courage and skill and tactical brilliance, collided with the material reality that modern warfare was decided by production statistics. The side that could build more ships, train more sailors, and sustain longer operations won regardless of individual battle outcomes. American shipyard workers, many of them women, minorities, and people with no maritime experience, built a fleet that decided the Pacific War as surely as soldiers and sailors fighting in combat. Every vessel welded in a shipyard in California or Maine or Virginia represented military capability that Japan couldn't match. The accumulation of those vessels into fleets of overwhelming size made Japanese defeat mathematically inevitable. The Japanese Navy fought courageously throughout the war. Japanese sailors and officers demonstrated exceptional skill and dedication, but they fought against an industrial system that could replace losses faster than Japan could inflict them. The mathematics of attrition warfare favored the side with superior production, and American production exceeded Japanese capacity by orders of magnitude that Japanese planners had thought impossible. From the moment Kaiser demonstrated that ships could be manufactured using mass production techniques, the outcome of the naval war was determined. The battles that followed were tragic and costly, but the industrial foundation made American victory inevitable. The 2,000 ships that appeared in 18 months proved that modern war was won in shipyards and factories as much as on battlefields.